The objective of Physics Lab Report 4 is to observe the motion of a spring mass system which is given excitation in such a way that it oscillates in both x and y directions simultaneously. I have set my origin at the fixed end of the spring. X axis is positive towards right and y axis is positive upwards. Let's now run this video and we see that the object directions here and we see that it will curve and we can see that going to use to build our computational model. Here again, if we plot x versus time data, we see that it follows a similar sinusoidal curve. We are going to use both these graphs to calculate the time period in both x and y directions. Let's now calculate these values. Here we have the mass and the initial position data, and we will calculate the time period in y direction taking out an average of 5 oscillations, which comes out to be 1.52 seconds. Using this time we can calculate the stiffness of the spring, which is 6.87 Newton per meter, and the initial length of the spring to be 0.126 meters. Using these inputs, let's build our computational model. We have the initial conditions from the video analysis here. Time delta t here is much lesser. We have defined the spring stiffness and the initial length, and here I have set the equation for the kinetic energy, gravitational energy and spring energies. The two forces acting in our system are gravitational force and spring force. Net force is sum of these two forces, and using Newton's second law we can calculate the velocity of the mass at a time delta t later, and using this velocity we can calculate the position, and then we can update the position vector and the energies. Here we are going to plot different forces in our output window, and I have used time scale 10 times bigger to plot a net force to have a better visualization. Let's now run this model. Here we can see this green color arrow represents the net force acting on the system. It's bigger because the arrow scale is 10 times bigger than the other two forces. The black arrow represents the gravitational force, which remains constant throughout, and the blue arrow represents the spring force, which keeps varying as the spring moves up and down. And if you look at the position data, here red color represents our observations from the video, and the blue color represents the computational model displacement, and we see that they follow each other very closely for our practical purposes. Let's now rerun our model. Instead of instead of plotting the displacement, we will plot the energies. I have already set in the code and let's run the model. So this video remains same. However, in this graph we are going to plot energies instead of the displacement now. Here we can see that the red color represents the gravitational energy, which is constant in magnitude and its oscillation throughout because the net force, gravitational force, remains constant. And the green color here represents the spring force, and it oscillates with the varying magnitude. We are going to discuss it why later, but if we see closely, both these have the same time period of oscillation, while the blue color here string here represents the kinetic energy graph, and if we see that it is having a slightly longer time period than the other two energies, and this is because the two energies, spring and gravitational energies, are in this case mainly dominated by the vertical forces or the forces acting in y direction, so they will follow the time period of y direction oscillations, while the kinetic energy is in this case dominated by the x component velocity. And we have seen in our previous analysis that the time period in x direction is slightly bigger than the time period in y direction. This is why we see there is a slight offset in the time period of these different energies, and because of these we are going to we are looking at these perturbations set into the spring energy and also to a small extent in the kinetic energies. That's all from me. Thank you very much for listening.